9.3 Summation Notation. Summation is the noun for sum, so that means addition. Notation is a way for us to write out sums. For example, let's say that f of n is equal to 2n plus 1. Okay? Then f of 0 will be 2 times 0 plus 1, which is 1. F of 1 will be 2 times 1 plus 1, which is 3. F of 2 would be 5. F of 3 would be 7. F of 4 will be 9, and so forth. We want to write f of 0 plus f of 1 plus f of 2 plus f of 3 plus, we keep going, dot, 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 plus f of 15 in summation notation. All right? So in summation notation, the point of summation notation is to have a way to write it short, much more concisely, short. Keep it nice and short. The first number is 0. So I'm going to use, let's say, n. It really could be any letter equals 0. The last one is 15. So I can write 15 right here. So I write the summation sign. On the bottom I write n equals 0. On top I write 15. What are we adding? We're adding f of n. Okay. Another way to write this that is equivalent. We write our summation symbol. Once again, we're going from n equals 0 to 15. Since f of n is 2n plus 1, you can just write it this way. So the summation, the first one they wrote, means f of 0 plus f of 1 plus f of 2, and so forth. Okay. Let's look at some examples. Example 1. We want the sum. We want to evaluate, so calculate the following. We want the sum from a to 0 to 5 of a squared. Okay. Well, that means we're looking for 0 squared plus 1 squared plus 2 squared and so forth, plus 3 squared plus 4 squared plus 5 squared. Yep. So that's 0 plus 1 plus 4 plus 9 plus 16 plus 25, which is 55. Okay. Example 2. The sums do not have to start from 0. Here's a different one. We want the sum from n equals 3 to 7 of 2 to the n power minus n. Okay, that means we want 2 to the third power. We start with 3 minus 3. That's the first term. Plus 2 to the fourth power minus 4. Plus 2 to the fifth power minus 5. Plus 2 to the sixth power minus 6. Plus 2 to the seventh power minus 7. Okay. And if we calculate that, we get 5 plus 12 plus 27 plus 58 plus 121. Okay. If we add these up, I go at 179, 206, 218, 223. Okay. Now, in our last lesson, we learned about Riemann sums. We can also write them in summation notation. We can write a formula for Riemann sums, the left and the right anyway, in terms of summation notation pretty easily. For example, determine the left Riemann sum for f of x using 8 equal intervals. We're given a table of f of x for x equals 0, 1, 2, 3, and so forth, up to 8. So we know the left Riemann sum is really, each interval is 1. So it's 1 times, the first interval is f of 0 plus f of 1 plus f of 2 plus f of 3 plus f of 4 plus f of 5, and so forth, up till plus f of 6 plus f of 6 plus f of 7. Okay. Because we're always using the left, that's it. So if we were to do that, that's going to equal to 1 times 13 plus 16 plus 18 plus 17 plus 19 plus 22 plus 16 plus 15. Okay? We can write the sum in summation notation. The f of 0 plus f of 1 plus f of 2 and so forth. That's going to be equal to, we have a sum symbol. We start at n equals 0. We go up to 7 of f of n. Okay. I can use x if I want, but it doesn't matter. We can use x, we can use n, it doesn't matter what letter. Okay, what about the right Riemann sum? Well, with the right Riemann sum, we don't start with f of 0. In start, everything else is the same except that we start with f of 1. And then plus f of 2, plus f of 3, plus f of 4, plus f of 5, plus f of 6, plus f of 7, plus f of 8. Because, for example, the interval 0, 1, the right Riemann sum uses f of 1 to evaluate. If we were to calculate that, that would be 16 plus 18 plus 17 plus 19 plus 22 plus 16 plus 15 plus 12 from the table. But really, the more important one is when those 1 times f of 1 plus f of 2 plus f of 3 and so forth. We can write this in summation notation. So let's do that. That's the sum. It's also f of n, but this time n goes from 1 to 8. This takes us to a general formula for left and right Riemann sum using summation notation. So we know that left Riemann sum starts at 0 and goes to n minus 1. For example, in our problem, we go from x goes from 0 to 8. Our left Riemann sum will go from 0 to 7. The right Riemann sum will go from 1 to 8. What are we summing? Well, we're summing delta x, which is the size of this interval. So for example, if we have a curve, the size of the interval, and we divide up into intervals, the size of the interval is delta x. For example, the interval from 3 to 5, the size of the interval will be 2. And then we also have our f of x, our points. So left Riemann sum and right Riemann sum, they're both delta x times f of x, I, where for the left Riemann sum, we're summing from 0 to n minus 1. For the right Riemann sum, we're summing from 1 to n. Okay, that's it.